Okay, so we're going to talk about another conservation law. And so I will give the highlights here to help students prepare for the AP physics test. So conservation of linear momentum. So this is one of the conservation law besides conservation of energy, conservation of mechanical energy, and conservation of angular momentum. So this is one of those. So what is the assumption that's needed? So the assumption is that external net force for the system must be equal to 0, right? Equal to 0. Okay, I cannot type. Okay, so once you have that, then you can say M1 V1, right, plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime, right? Okay, so here V1, V2 are the original velocity for M1 and M2, right? And then V1 prime, V2 prime are the velocity for M1, M2 after, right? Immediately after, right? Immediately after collision. Okay? So that's in this conservation of linear momentum. What we mean is that the sum of linear momentum, right, for the system, and the system here is M1 plus M2, right, is the same during the collision, right? Okay, and that include before, right before, and right after. Okay, so that's the idea. Okay, whenever you don't have any net external force for the system, then you can say this linear momentum, which is in P, right? So P1, so P is equal to P prime, right? And which is equal to constant, okay? Or you can say P1 prime, not P1 plus P2, which is P, is equal to P1 prime plus P2 prime, okay? So all these are acceptable, and P here is the linear momentum, right? Okay, and of course P1 is the linear momentum for M1, right? M1, okay? And so we're not going to talk about collision here, but there are 3 kinds of collision, right? 3 types of collisions, right? And they are elastic, okay? And then inelastic, and perfectly inelastic, okay? And so we're not going to talk about it, but just keep in mind there are 3 types of collision that usually you will apply this conservation law to, okay? And that's it for today, is the conservation of linear momentum. Hopefully you learned something today. Bye-bye.